Hi there, this is Jacob Nash, Precalculus Lessons. And this is Unit 4, Lesson 4, on Radians. Sorry about my last videos that I made in this unit because they had terrible audio, but I already said this before, I don't really have time to re-record them, so sorry about that. It's not like I have more than 0 views on these videos anyway, so if you happen to be the one person that sees this, there you go. But you're probably the only one as of 2021 anyways. So, no need to do that. It would be different if I got like 1 million views or something. Okay, so lesson 4 is on radians, and what are they, okay? Well, you might have remembered in Algebra 2, you learned a little bit about that in the unit circle, which was the last thing that you might have done. At least it was the last thing that I made videos on. Seems like it was 1 million years ago when I made videos on that, but it was really just May. So 6 months ago for me, because it's November. And a cool thing is, well, I don't have the intro today, but the intro for this YouTube channel is a Black Keys song, same old thing. And the drummer of that band said something to me today on Instagram because someone hacked, well, I'm getting way off topic, but someone hacked Instagram account for the person that dances in their music video Lonely Boy, and I was trying to get that figured out because it's a little crazy. I don't know, but that's not what this is about, because you might not even know what that is anyways, who the Black Keys are, but it's a good band, that's all I can say. But anyways, radians are just another way of measuring angles, like degrees. We can measure angles in degrees. We've seen that in the last few videos, and you know that already. But radians are just another thing, like how there's inches and centimeters, kind of like that. So it's just a little bit different because sometimes radians aren't listed as with units, like how we have the degrees with the little dot for degrees, but you just not usually don't put any units for this. So one radian does not equal 180 degrees, which is something sometimes people think. Pi radians equals 180 degrees. So you might say pi. Well, remember that thing? That just means 3.14 or whatever the other numbers there are. So that about 3 radians is 180 degrees. Here is something that you can see to show how much radians are in a certain amount of degrees. So 0 degrees, let me change this to green because I already have this blue. So 0 degrees equals 0 radians. That makes sense. What we already said, 180 degrees equals pi radians. So we would only make sense if you half the amount of degrees, that so would the pi amount. But you sometimes see this listed as pi over 2, but that's just the same thing. Hopefully you know that, but that's okay if you didn't. But you usually see it written like that. But pi over 2, or 1/2 of a pi radians, equals 90 degrees. 270 is 3/2 pi radians, which you also might see as 3 pi over 2. Same thing once again. And also, even though it's not on here, if you made a full rotation, 360 degrees is 2 pi radians. And I just say RAD. So your calculator can be in radians or degrees if you see rad, deg. But we're not doing that right now, so it doesn't matter. Okay, we're just going to convert between them and see how to do that. It's not as hard as it might seem. It's easier to convert to degrees, in my opinion, than to convert to radians, but that's okay. So we just use this, that pi radians equals 180 degrees, to figure it out. So what you can do when you're converting to degrees is you replace pi with 180. You can do that, but if there is no pi, like the amount of radians it doesn't have pi in it, then you're going to have to use a conversion factor. And I'll show you what it's like, how you would know. Number 3, as you can see, has no pi in it, so we'll have to do that. Okay, so number 1 says 6 pi over 7 or 6/7 pi. They mean the same thing. You won't ever have a or thing. I just read that so that you can understand that those are the same thing. So 6/7 of a pi radian. Well, a pi radian equals 180 degrees. So if it's 6/7, we at least know it's going to be a little bit less than 180 degrees. But how do we know for sure? Well, we just replace pi with 180. I'm just using this right here. And of course, I'm going to have to get my calculator, but I might as well just put it on, look up the Wabbit Emu thing that I've used before. If you heard that, that was, I don't know if you heard that, that Windows noise that usually happens when you can't type in something. I make it a black keys noise. I changed my computer, but this is frozen, and I don't know if this video is even working anymore. That's just great. It should be working, but the files thing is messed up. I should have pinned the Wabbit thing. If that's even how you say it, I don't know if that's just made in some other country or something. All right, W-A-T or W-A-B-B-T or I-T. I don't even know how to spell it. Okay, and it froze once again. And that means I'm going to go get my calculator. I'll be right back because that's not working. Okay, I'm back. Sorry about that. I don't even know. Technology has just been so dumb lately. That's why I'm on my computer and on my iPad anyways. That happens to equal 154 degrees if we were rounding to the nearest degree. And like I said, that is pretty close to 180. All right, number 2, do the same thing. You have 3/4 of a pi. So just instead say, replace it with 180. So 3 divided by 4 times 180. That's what we're doing. So let me do this in my calculator. Times 180. It's 135 degrees. Okay, good. But this one doesn't have pi that we can replace 180 with. So we just have to use our unit conversions. And hopefully you know how to convert between units. So like if someone said convert 12 inches to feet, hopefully you know that's 1 in your head. But how would you actually do that? You have to use the conversion factor. And what that is, in case you didn't know, is just something that tells you 2 things are equal. And in this case, pi radians equals 180 degrees. Since we know that, that's how we can do this. So we start out with 1.272 radians, and you have to multiply it by something. What is that something? Well, it's a fraction that has a conversion factor on it. So it's going to have these 2 things, but which one goes on the top and which one goes on the bottom? The one that goes on the top is what one you want to convert to. So why? It's because we need our units for radians to cancel out. And if radians is on the bottom, then they will cancel out, and then what will be left is the degrees. So we're going to put 180 on the top in this case, and pi radians on the bottom. This would just mean that the radians cancel out, and then we end up just multiplying by 1.272 times 180 over pi, and then our answer will have degrees as the unit. So remember, whatever you're converting to is what's going to be on the top. What you already were given goes on the bottom so that you can cancel it out. It's just a little unit conversions lesson, but You probably already know how to do that, but that's okay if you don't. But so I'm doing that in the calculator, and in this case, you want to use the pi button, not 3.14. And that gives us, if we're rounding to the nearest degree, 73 degrees. There we go. That is converting from radians to degrees. For degrees to the radians, you always have to use the conversion factor like we just did in number 3. So we're starting out with 47 degrees. We need to multiply it by the conversion factor. What goes on the top? What we want, which is radians. What we already have is degrees. And what's in the conversion? We have that pi radians equals 180 degrees. So we multiply 47 times pi divided by 180. Make sure you have your parentheses where needed. And let's just round to 3 decimal places. 0.820. And you don't always have to put radians. Oh, I forgot to say, that is rounding. If you wanted to have the exact number, what you would have to do is say 47 divided by 180, and then math fraction 47 to 180 over 180 is the simplest fraction that can be. Let me try to get my calculator back up so you can see what I mean. But that would be your exact answer. Oh, didn't show it. That would be, this is your exact answer, the exact number. This is just rounded. So depending on what your teacher wants, if you notice what we did is we just took those two numbers and made them a fraction with pi by it. But sometimes this can be simplified, and you can do that with your own math skills or with the calculator. And let's go for it one more time with pulling up this file. Maybe I should just X them out. File Explorer. Okay, it's obvious that that's not going to work. So basically, we'll just see how the other examples end up like, but okay. So now we have 180. Well, don't we already know that 180 equals pi, 180 degrees equals pi radians? Yeah, but let's solve out the conversion anyways. So this, we want to find radians. We are given degrees. Our values are 180 and pi. But if you notice, the 180s would cancel out and we would be left with pi radians, which is what we know the answer is. And if you actually type that into the calculator, you would get 0 or 3.14, whatever. So that is the answer. And you don't always have to put radians as your units, but I just did in that case. It's not really a unit anyways, but I just put it there. So 91 degrees, we're trying to find the radians. You're given degrees, the values are 180 and pi. Just remember that don't always do this for what you multiply by. If you already are given radians, the fraction flips, as we saw in this number for 3. So what we want to do, if we want the rounded answer, 91 times pi divided by 180, that is 1.59. Oh, wait, we did 3 decimal places in the last one, so 1.588. But the exact answer would be this. And let's see, if 91 divided by 180 has a simpler fraction, no. So we leave it like that. So either one of these is your answer. Okay, that is not that hard if you think about it. So just remember, radians are just another way of measuring angles. But now that you know how to do that, we're going to have to apply what we did in the last lessons. We need to find the coterminal and reference angles when the angles are in radians also. And there's 2 ways to do this. You can convert to degrees and then back to radians. If you do that, that is easier to some people, and that's honestly what I would want to do. But another thing that you might want to do is just stay in radians And I'll show you how to do both. So we have two problems here. And on the first one, I'm going to convert to degrees and then go back. And then the second one, I'm going to just stay in radians. Okay, so for this one, we're trying to find the coterminal angle that must be between 0 and 2 pi radians. Well, 2 pi radians already said was 360 degrees, and 0 is just 0 degrees. So really, that just means it needs to be between 0 and 360 degrees, which is what we already said. So 237 pi. How do we change that to radians? Or sorry, how do we change that to degrees? Well, in this case, since we have a pi, we can just replace it with 180, and that's going to be a heck of a big number. You can already tell, but let's see what it is. Well, it's actually not that big. 42,660. So 42,660. How do we find the reference, or sorry, how do we find the coterminal angle? We'll just do that first. It has to be between 0 and 360 degrees. So what we need to do is keep subtracting 360. If you add or subtract 360, you get another coterminal angle, but we're subtracting because it needs to be as low as 0 to 360. So let's just do minus 360, minus 360. And this is going to take a long time. And you could just divide by 360, but since this one's not super, super big. Okay, well, actually, that would take a long time. So what we actually do, I already showed you in the last video. So please watch the coterminal angles video if you don't understand what I'm doing. But remember, we divide that by 360. That is 118.5. And we only want the 0.5. Now we do 0.5 times 360. And that is 180. So the coterminal angle is 180 degrees. There we go. The reference angle, well, we first have to figure out what quadrant is this in. Well, it's hard to tell for that, but we can tell by this. But hang on a second. There's something that I forgot to say about reference angles. There's never a reference angle for angles that are 0, 90, 180, 270, or 360. 0 and 360 are kind of the same thing. But the ones that end up on the axes are never, they don't have reference angles. So we can just say none. There is no reference angle for this one. So that was the converting. Oh, see, that's the problem. That's one problem with doing this first method, converting degrees, I said, and then back to radians. We have to convert 180 back to radians, and that happens to just be pi. That one's the easy one. But you got to make sure you convert back to radians. Now we're doing one where we're going to just try to stay in radians. It's what they would want you to do in AP Calculus. So this really means this. And what we need to do is multiply the denominator by 2. That's the first thing you do. Sorry that I didn't write out the steps, but just if you're taking notes, write that down. And that would give us 66. Now what do we do? Well, we would divide 129 by 66. That gives us, we're just ignoring the pi for a second. So that's really what you do. So I should just write down the steps. So denominator times 2. Forget about pi. Then you numbers after decimal times the denominator. Put back the pi. because these are really number steps. Okay. So the denominator times 2, that would give us 129 pi over 66. Let's do this. Now we forget about pi, so we just have 129 over 66. We're going to make this a decimal, and that gave us 1.9545, and the 4 5s repeat. We only want what's after the decimal. Remember, that's kind of like when we were finding the coterminal angle for degrees. So we, in the calculator, we just can subtract by 1 to get only the decimal. Multiply that by the denominator, which that would be times 66. That gives us, a whole number, 63. And that would mean 63 pi. We put back pi. 63 pi is the coterminal angle. But we got to make sure, is that, oh, wait. Before we go, is that between 0 and 2 pi? No. So sorry about that. That is not the coterminal angle. What we have to do is subtract by 2 pi until we get something that is between it. So this is why I don't really prefer this method, because it's a little bit trickier. But yeah. So I'm not going to go any further because that's just a little bit crazy. I really do prefer the first method, but so let me just go ahead and do that. So that we had 129 pi over 33. To get it into degrees, replace pi with 180. It's going to be a pretty big number. Not really. So that's the answer for that. We only want the decimal, so 0.6 repeating, 63 repeating. Multiply that by 360. That gives us 229. Is 229 between 0 and 360? Yes. So coterminal angle is 229 degrees, but we need radians. So we will multiply by our conversion, which would have what we want is radians on the top, degrees on the bottom, value is 180 in pi. So 229 times pi divided by 180 is, I actually said minus on here, times pi over 180 gives us 3.997 radians. And is that in between 0 and 2 pi? Yes. Another thing, that is our rounded answer. We also can do 229 over 180, or 229 pi over 180 radians. And that is in between 0 and 2. That is our coterminal angle. So either way, it's a little bit complicated when you have radians, but I prefer this method. So we still need to have our reference angle. So what quadrant is 229 degrees in, or 229 pi divided by 180 radians in? Well, if we were trying to draw this and it's in standard position, it would look about like this, with this being our angle measure of 229 pi divided by 180 radians, or 229 degrees. And that is in our third quadrant. That's what this is. So that means we use angle minus 180 to figure it out. The angle is 229. And where did I get that from? That's from the table that I showed you in the last video. So make sure to watch that if you don't understand how to get a reference table. The answer is 49 degrees. But is that what we can have as our answer? No. We need to have 49 pi over 180. That's what we would get when we did our conversion factor. That's our exact answer. Our not exact answer would be 0.86 approximately. So a little bit complicated, but really radians are just another way to measure angles. And you need to know how to convert between them. And whichever way you prefer, really, to do that, I pretty much just showed you number one. I kind of failed with number two. But anyways, so that would be it for this video. Thanks for watching, and I'll see you on the next video.